Hello. My name is Weronika Łabaj. I work as a principal architect for a consulting company called Inventive. And today I wanted to share a case study, so tell you in a bit more detail about my most recent project and how we modeled fragment of a domain in that project. And I think it's quite interesting for a few reasons. So one of them is that it's actually a third attempt at rewriting a certain system. So the first one was partially successful. They added a web app that was adding some new functionality, but failed to replace the old existing system. And the second reason why this project is really interesting is the domain itself, which is, I think, very unusual. So that system has been used by a certain dog organization to manage all the work they do. For example, they run a registry of purebred dogs. So they keep track of family trees of dogs, they issue pedigrees, register breeders, and things like that. But also they do dog sports. And coming to this project, I had no idea how many different sports there are, or that there are any. So just wanted to give you a couple of examples. For example, you have working dog competitions for shepherd dogs that work on the farm. And they have to guide a group of animals, either cows, sheep, or ducks, from one point to another, following certain route. And they have to maintain good shepherding standards. So, for example, maintain good eye contact with the animals they are herding, or maybe bark, not bark certain way. All those elements are being judged. And you have another sport called agility, which is the most popular all over the world. And it's essentially a track with obstacles. So dogs are jumping, running through tunnels, and doing all sorts of crazy stuff. And they try to do this in the shortest possible time. So it's very spectacular. There are many videos on YouTube, so I encourage you to have a look, because it's really amazing what those dogs can do with their handlers. And in this talk, I wanted to focus on really a single business process called titling. So when you organize a dog sport event, this is something that can last a few days. Most typically it's 2 or 2.5 because it's organized over the weekend. And each day you have many shows or trials. And those events are not, most of them are not directly organized by the headquarters, by the main dog organization, but by some partners that are licensed to do this in their name. And after the event, they have few weeks for submitting the show results. And then person in the office that is responsible for managing a given type of sport is entering those results and running this process called titling. And that process essentially tells us if a dog should be awarded any new titles. If they do, then a few things happened. So for example, they print and send certificates to the owners so they can frame them, hang on the wall, and post all over their social media, which they absolutely do. And also we update a dog name. So at the bottom, you can see this is an actual name of a dog, except the middle part, right? So that one is made up because they tend to be more fancy. But the prefix and suffix of a full name of a dog are a combination of some selected titles that that dog has earned. So as you can see, over time, there can be really many of them. This is just a subset of those titles, because not all are included in the name. And here you can see a title progression for one of those programs. Let's call it R. And from the development perspective, this is a medium complexity program because it has 26 titles. Some others have 2 to 184, so pretty wide range. And also the rules for awarding titles are kind of complicated, but it's not the hardest program to implement. And most of the titles are one-off, but you also have a concept of progression, which means you can be awarded the same title over and over by fulfilling the same criteria multiple times. So here are actual examples of rules for awarding titles. So that list is not exhaustive, it's just a few examples. So the most popular rule tells you that you need a certain number of qualifying scores from few different judges. And what qualifying score is depends on the type of sport, the level, class. The threshold of points may differ, so it might be 170, 190, 195. And that part about few different judges is interesting because it turns out that in the dog sports, many people know each other. And you have whole families that are judges, breeders, that are very active. So that part of the rule is ensuring that you're getting objective evaluation of the skills of the dog. Then you have other titles that are awarded if you have a combination of other titles. So they're not directly based on show results, but on some other titles. And finally, you have more interesting requirements like for reg. So here you have a combination of requirements, right? So your dog has to compete on 2 levels in a single trial. On each level, it has to cross that threshold of 170 points, so it has to be double qualifying score. And over a series of events, they have to accumulate 100 points, calculated according to that formula, and at least 5 scores have to be above 195 from 3 different judges. So if your dog gets the maximum score of 200, then it takes 10 shows to get that title. But in practice, it's like 15, 20, maybe even 30. So pretty huge effort, and people care about this a lot. Just attending the events to get that title sometimes requires travel because there's nothing in your area. So it's money, time, effort. And they also prepare for those events, right? It's not like you can just decide to go tomorrow with your dog to this event. People train, go to special classes, and practice for a very long time. So they really care about those titles. So titling was a small part of the overall rewrite. And when we were planning the project, we were wondering how to approach this, right? We knew this area is quite complicated because of all those rules. There were about a dozen sports, it depends how you count some of that, and over 300 titles, right? And there were no automated tests. We knew that manual verification of a single title to the business expert could take over 1 hour, because to devs it would take longer, right? So sometimes you had a few hundred show results, you had to, I don't know, print them, color code, count the points, double, triple check, and it was very, very mundane process, right? We also learned that some parts of those programs were never fully implemented. So a person in the office that was managing that program knew that they run calculation, and then they go back because they knew in a certain situation they had to go back, manually count titles, remove some, add some others. So there were some gaps. Also, since the data entry was manual for the most part, there were many mistakes. So things that shouldn't happen, they happened all the time. So for example, you could assign the show result to the wrong dog, or you could pick a category that didn't exist in the given program. So then that result would be skipped. So over the years, we had many manual corrections of titles. And also interesting characteristic of the system was that the show results were entered and processed out of order, right? So you had kind of eventual consistency. That was caused by the fact that you had different organizations organizing those events. So if you had 2 that had event on the same day, it might be even a month or 2 months difference between when those show results were being processed. So that was an important aspect to take into account in our implementation. So given all that, we felt like, maybe we shouldn't reinvent the wheel. We should just try to take what we have. And we had some code from the second rewrite that never made it into production, but that was automatic conversion of some very old version of Visual Basic into C# and .NET. So it was compiling, it was somewhat running, right? So we felt like, okay, we can, just tweak it, maybe refactor a little bit, add those missing parts, and we should be good to go. So that's what we tried to do. Interestingly enough, in that old system, the requirements for the titles were also stored in the database using some canonical format. And you can see this is an actual example of one of those requirements, how they were modeled. So the key part is that number 4, right, the red one, 3 qualifying scores above 170 from 2 different judges. Then you had that part telling you that it needs to be advanced level, class A or B, and before you get advanced title, you need to already have novice title, RN, and you cannot already have RA because it's a one-off, right? You get it only once. So we felt like, okay, maybe this is not really elegant. Maybe we could come up with some better representation. But, 300 titles, well, we don't want to kind of rewrite this and start from scratch, right? So we felt like, okay, we can understand it, so we'll just leave it as it is. And then those rules were picked up by some rule engine. Maybe it's a bit too much, but some algorithm to process them, right? And you can see on the left, I described that algorithm using terms that we found in code and in database. And on the right, you can see the same thing, but using terms that business experts were actually using. So right away, you can see our first challenge, right? The rules were really complicated. That domain has a lot of jargon. It's really overwhelming. It takes a few months to fully understand what people are talking about. But when they said something, it took us really long time to find that thing in code because the names were completely inconsistent. So first, I wanted to clarify those few basic terms. So because I'll be using this later on, right? So it's relevant. So the program is used in a sense of a competitive program. It's a type of sport. And within each program, you have multiple types of titles. A show is a single round of a competition, and there might be many of them per day. And title is achievement of one dog that has certain type and is awarded based on show results or other titles. And show result is a record of an individual score. It has certain attributes. Two I wanted to highlight is two concepts related to show results. So used show results meant that that show result contributed to some title. Therefore, in certain cases, it shouldn't be reused or recalculated for other titles, right? You would exclude that. That wasn't true for all titles. It depended on type of title, but in many cases, that was important. And also, we had a concept of leftover points. So in a situation like with Reg, when you try to accumulate 100 points, maybe you have 98 and then get another 5, right? So you only need those 2 to fulfill the requirement. So the last 3 would be left over, and you can use them in a subsequent title in the progression, for example. And this is how the program would work. So a person in the office would pick a program for which they would run titling. And first, we would get all types of titles from that program. Then for each title, we would get those requirements from the database, and we would also check when that was last evaluated. So based on that date, we would get a list of candidate dogs, so meaning dogs that had any new information that could contribute to title, and that might be based on unused show results or other titles that they have been awarded since then, right? And then for each dog, we would get, for each candidate dog, we would get list of their unused show results, titles they already got, and leftover points, and verify the requirements. If they were met, then we would just persist the new title, mark some show results as used, so next time we calculate, they are excluded. And if there were any leftover points, we would also persist that information and move on to the next title. So it wasn't easy to figure out how to tweak some of those rules and address the things that we knew weren't working in the code we inherited. But we felt like we were making progress. We had a long list of dogs that we used for testing because the experts already had a long history of working with this program. So they knew what dogs in the past caused some issues or which were interesting for some reason. And we felt like, OK, we are probably nearly done. We are making pretty good progress. And then it turned out that there's issue with the reg progression. So suddenly, the experts realized, OK, we are awarding a pretty big number of those advanced titles, like reg 4, 5, 6, and they're pretty hard to obtain. So that seems off. And they started digging into this, and it turned out like they shouldn't be awarded, right? So first, we went back to the database, and I just wanted to highlight that part in red, right? The 5 scores above 195 from 3 different judges. And here you have definition of requirements for Reg 2, so second one in progression. And you can see that actually that part of the rule is defined as 10 scores above 195 from 1 judge. So first of all, we have one obvious bug, because it should be 3 judges, not 1 judge, right? But also that part with 10 scores was kind of tricky, because it's not exactly the same as 2 times 5 scores, right? So we defined that scenario you see at the bottom, so and ran it by the business experts and said, let's say your dog competes in 10 shows, always gets the maximum score of 200. And then for 25 shows, they're really unlucky, always get 194. And the question is, should that Reg 2 title be awarded? And according to our calculation, yes, it would. But according to the experts, it shouldn't be awarded, because those 5 qualifying scores above 195 were awarded while they were working on the first title in progression, which is not exactly the same, right? So that's just one nuance we discovered, but of course there were many more when we started digging into those more complicated titles. So the really scary discovery was that we had 9 types of rules in the database, but only 7 were actually handled in code in any way. So we started wondering if actually the source code we had was the same code that was running in production, and there was no easy way to verify this. Also the rule engine itself, I showed you like the pseudocode for this, right? But it was really complicated code to work with. It used recursion. The calculations was based on, state persisted in the previous calculation. So if you made any mistakes in the previous calculation, you would get garbage in, garbage out kind of situation, right? And the errors would accumulate. Debugging was very hard to follow the flow of recursive algorithm when you have to iterate over a few hundred results just to get analysis of a single title. And also reproducing issues was tricky because of that persisted state, right? So if they executed that process a few times per day, in order to fully accurately reproduce the issue locally, we would need to get a few snapshots per day of the database and each time use the correct one for debugging, which was like not very practical, right? And last but not least, the code was very hard to refactor to make it testable, much harder than we initially expected. So after struggling with this for a while, and after a few sleepless nights, we decided to have a conversation with the experts. And we said, listen, we can keep trying, we can continue down this path, but it seems like it's not really working, right? Because despite really huge effort, that code just doesn't make sense. And the longer we stare at it, the less sense it makes. So maybe we should try something else. It wasn't our original plan. It would take longer than we initially expected, but either way, it didn't seem like we can get anywhere with what we already had, right? So luckily for us, the experts were courageous and maybe desperate enough to agree to that idea, and we did Spike, POC, for that program R I mentioned. And we just wanted to verify that we can really find a better model and that would actually help, that it would be easier to rewrite it from scratch than try to keep trying fixing the existing implementation. Also, we knew we had to make it testable because manual verification was just impractical. It was very difficult to generate those test cases. The verification took too long, and regression testing was just impossible. And also, we wanted to provide some tooling to make calculations easier to validate, both for experts and for us. So first thing we did was borrow that technique from legacy code retreat called golden master testing. And in that technique, you treat your existing system as a black box. So you probably don't understand everything about how it works. But what you can do, you can generate a large number of inputs and then see what outputs that system is producing for those inputs, and record this somehow. And then as you keep changing that implementation, or maybe as you build something new on the side, you keep comparing if for the same inputs you're getting the same outputs. And what was really great about our system was that we already had that data. And we had hundreds of thousands of test cases. Some of them were 40, 50 years old. So really a lot of data. All the possible scenarios you can imagine probably happened over that time span. And even better, we didn't have to rerun this calculation with the old system because that information was just stored in the database already. So our inputs were show results, outputs were titles of particular dogs. So technically, that was very easy from the technical perspective. The tricky part was figuring out what to do when you discover the difference. Because it might mean that we didn't know about some rule, or maybe we made a mistake in the new implementation, but maybe we just fixed the bug in the existing implementation. And then you have this kind of philosophical question, like if a bug exists in production for 5, 10, 20 years, is that still a bug, or maybe it's a feature, right? And if it's a feature, what should happen as a consequence? Maybe you need to update the rule book, let people know this is how that rule should be interpreted, right? So that part was really tricky, and that required very close collaboration with the experts. And luckily, we had that. So whenever we discovered some difference, we said, listen, this is the scenario we have, this is the old output, this is the new output, tell us what we should do, which one is correct. And to help them a little bit with this, we provided that visualization tool. And I cannot stress enough how powerful that was, not just for the experts, but also for us, so we can, within the dev team, discuss some nuances. The idea was very simple. So for one doc and one program, you would show list of their show results. And that could be filtered, sorted. It could be also grouped, like here by show ID. And right away, you can see some interesting things, right? So for example, so one important aspect was that if a particular show result contributed to some title, you would get this colorful badge telling you what title has been awarded based on that show result. So right away, you can see the first result I highlighted is a lonely show result, is a single qualifying score. So this one is not being used for awarding reg. And that's correct, right? One quick look, and you can see, OK, that's how it should work. Then you have the second one I highlighted, and there's one show result that has 2 badges. So the question is that how those leftover points work? Does that program even have that concept? Is that OK? So very quickly, you could sort out some nuances that were very, very hard to describe using words and by just listing show results in some tables. And I'm going to share some highlights of the implementation. So that's, of course, this is not full code because there's not enough time and space to dig into this. But I just wanted to show highlights, interfaces, also to give you some idea how we approach this. So the first thing we did was we had that definition of show result. So each show result has certain attributes, and among others, it has class and category, which were, there was a specific set of allowed values that we represented as enums. And then we had title with audit, which was representing a title for a particular doc. So of course, it had type of title, again, represented as enum, but also it had that list of related results IDs that we used for visualization, for tying the show result back to the title. And then you had that method that actually did all the heavy lifting. And you can see that our only input were those show results. That didn't depend on any internal state or global state, didn't touch the database. The only output were those titles with audit, right? So it was also a pure function, no side effects. And you can see right away, it was very, very easy to test. Inside, it could get really complicated, but with automated testing, that complexity was easy to manage, and it was very well encapsulated within that method. So after, I think, maybe 2 weeks, we had that visualization tool. We had tests. We implemented all the rules that we were struggling with for a while. And we felt like, OK, we can move forward. We discovered some new issues while working on on that implementation, but all could be resolved pretty quickly. So we felt like, OK, that's the path forward. We'll do that. So we moved on to the next program. And here we needed some small refinement. So turns out each program has its own classes, categories, and titles. So we just did small refactoring. We had a base class, and then each program had its own representation of the show result that was derived class, and added those parameters of class and category. So it was generic class, right? And we did the same for title, but in this case, you would pass title type as a parameter. And the interfaces of the methods were updated accordingly. So pretty simple refinement, right? And then we moved on to other titles, and it turned out that actually we made a bit premature optimization because it turns out that not all programs have the same number of attributes or the same names or the same types, right? So we had a certain number of attributes that were common among all programs, and then each program has its own additional attributes that were program-specific. And you can see in the R program, actually, we even changed the name of the parameter from category to level, right? Because also the vocabulary the experts used in each program was different. And after implementing this for all those programs, we moved on to implementation of the overall processing algorithm that would replace our previous rule engine. And by then, I think we were talking with maybe a dozen experts, business experts. So different people were specializing in different programs. And it turned out that some things we thought we will be able to hash out pretty quickly turned out to be quite complicated. So for example, sometimes experts disagreed with each other, or they discovered the old implementation didn't exactly work the way they wanted, right? So we had a lot of issues like that that we needed to resolve. And we realized we are not able to resolve all those issues before going into production, because that was impractical. We only wanted to be kind of reactive and fix things for dogs that were still actively competing. And we came up with a solution. We introduced additional step in the process. So you could rerun calculation on the same subset of data, and you can see in the calculation summary, we run calculation for 1,659 dogs each time. But then the number of dogs with new titles and with deviations or missing titles is changing. So between calculations, you could go back to the system and correct some data. Or if we discovered a bug, we could go back and change the implementation, release new version, and rerun calculation with the updated version, right? But until you approved that, nobody would see it. So only after approving, those titles would be actually persisted, and the owner of the dog could come to the online portal and see it. So to review the details, the experts had this calculation summary, so that was showing you what new titles were awarded, what were missing, and also they could drill into details by going back to that titling review tool for an individual dog. And the new process, as you can see, got a bit simpler, more concise. Right? The code was much, much simpler, and there were a few seemingly small changes, but had huge impact. So our input still would be program, but the evaluation date would be stored on that program level. Based on that date, we would get a list of candidate dogs, but not based on unused show results or previous titles, but just show results. Then we would calculate all titles, not just new ones. So we needed additional step here to compare what we calculated with what was already there in the database. And we would get three categories of titles. So the same existed in both places. So we would ignore that. It would just confirm that, yes, our implementation was the same as previously, giving us the same results. The new ones would be persisted as that summary information. And the missing titles were the most interesting category, because those were titles that existed in the database, but we didn't calculate them, right? So there was something off, and that required some digging to determine what was the source of that difference. And then we would just persist summary information on a dog level and overall calculation. And then sometime later, after validating those results, the person could approve the calculation, and we would only persist new titles. So we could also easily remove missing titles, right? But that was quite sensitive from the business perspective. So we didn't want to handle that. That was done manually by the experts. We would never mess with the information that was already there and change it. And the key differences I wanted to highlight, so all rules were implemented in code. We didn't use that canonical model from the database. We weren't sure if all those rules were actually correct. We discovered so many differences. But another benefit of that was that it gave us greater flexibility. And the code got much simpler, because different programs have actually different kind of rules, have different vocabulary, and it was quite tricky to come up with a canonical model that would encompass all those different options across dozen different programs, right? Also, the consistency boundary for our calculation changed from title type to dog, which gave us potential for running things in parallel, because types of titles depend on each other, right? So you can't really run this in parallel, but titles of one dog don't depend on titles of another dog. So here is your optimization, performance optimization potential. And finally, our calculations were based on raw data, on show results. So even if we made a mistake in the past, the next time we run calculation, we would catch it, we will see it, and you can correct it. So the errors won't accumulate over time and eventually would be corrected. And from the implementation perspective, this is not full code, probably that won't compile, but just to give you some idea how that was implemented. So that was essentially a template method pattern, right? So very basic one. You would have few abstract methods that were implemented in the deriving classes for getting results categories appropriate for the given program, for mapping show results to the representation for that program, and for actually calling that method that would generate the titles, right? And then you would have a sort of a template of the algorithm that would use those methods to calculate things. And then each program would have its own derived class for generator, where they would implement those abstract methods. And you can see here in the A program, one thing I wanted to highlight. In this case, we had a situation where one record in the database should be mapped to one or two objects in the in memory, right? So it was really very flexible, and we could do a lot of program-specific stuff using those methods. And then we had one last program to implement, and we called it Multitalented Doc program. And you can see in the summary information that you have a small difference here, right? So your input won't be show results, but those would be titles from different programs. But other than that, the calculation would be very similar. It would be the same pattern, right? You would have candidate docs, you would calculate the titles, persist information about which were new, which were different, and the whole thing was pretty much the same. So we made another refinement. And again, that was rather simple. So from that template method, we extracted two additional methods that would get us candidate docs and actually calculate the titles. So those few lines were previously existing in that execute method. And then they would be overridden in the multi-talented titles generator, right? So again, pretty simple. The old implementations wouldn't change at all. But in multi-talented doc programs, we would get candidate docs based on titles, not show results. And also when we calculated titles, we would pass in the input certificate titles instead of show results. And the overall outcomes of this rewrite effort for that process, at least, was that we released that version into production a few months ago. There were maybe 2 or 3 minor issues found that we since fixed. All existing functionality was replaced, and we also did a lot of extra stuff. So apart from that, the fact that it was testable, that we implemented all missing methods, we had visualization tool, we had also a few other features. And I know that probably you are not working on in the same domain and you don't have the same problem, so it's very difficult to copy the patterns, right? That's not maybe that useful, though I hope it was interesting. But I think that in our project you have some universal lessons that can be really applied to any project. So the first thing we learned that complex problems can be solved with simple code. And by far that one was from the domain perspective, from the requirements perspective, that was the most challenging piece of software I worked with. And many times during the implementation, we're kind of losing hope that we can understand it because there were so many terms, right? So like credit scoring, royalty calculation, that's nothing compared to this. But in the end, we ended with that trivial code, right? So what was that? Like template methods, some basic inheritance, nothing fancy, right? But when we started, we really expected we will, this is just a starting point. It will evolve. We will end up with something more complicated. But that never turned out to be necessary. The second thing we learned is that it takes time to find the right model. It's a really messy learning process, and usually you do just small tweaks. You change the name somewhere, maybe you do small refactoring, extract something, but over time it adds up. But it's not always forward movement, right? Sometimes you have to go back and remove something you did, like we did with the show result. And there were many other examples of this. So your design needs to be constantly reevaluated against whatever new you learn. And I know it's really easy to say bad things about legacy code, right? But I really believe that when that previous implementation was created, it made a lot of sense. But the problem was that it was 20 years ago, and new programs were being added, new rules were being added. Different people managed those programs, and they kind of diverged. They moved in different directions. So the common model started to be more and more complicated. But nobody stepped back and checked if that is still working, or maybe it needs a change. So it wasn't necessarily a bad design. It was just not longer satisfying the new requirements. Also, I think it's very important to find a balance. And that's probably the hardest part in finding good model, because sometimes you have to push back, and sometimes you just have to do what the experts tell you to do. And when you're just starting with a new domain, it's very difficult to understand which of those concepts are crucial, and you just have to do things as they tell you to do, and where it would be helpful to challenge and maybe change something. So you constantly need to rebalance and try things and see which way it will go, right? So sometimes you have to push back, as we did, and we added new step in the process. And that was easy change. Nobody objected. Everybody could understand after one sentence why we needed that. But when we wanted to get rid of those rules in the database, that was hard. Because the experts felt like, OK, if we have those rules in the database, we can go and change them. And we don't need devs to release new version, right? We can do it ourselves. They never used that option for at least 15 years. Because nobody knew how to do it. But still, it was very hard to let go of this idea that it could work that way, right? And we had to convince them, in theory, yes, possible. In practice, it's making our lives so much more difficult, and it's getting more expensive, right? So sometimes those conversations are very hard. On the other hand, you can take it too far. And as devs, we have to remember that it's not our place to tell other people how to run their business. So sometimes you have to accept that things are messy, they don't work the way you would like them to, they make your life difficult. So for me, it was very hard to accept that we can't prevent those mistakes, that we can't just go back and fix all the data and predict all possible ways in which the information can be messed up, right? So instead, we had to find a way to make them easier to catch and verify, and that was acceptable compromise. I also didn't like that eventual consistency thing, right? That we enter show results and process them out of order, because that means that at any point in time, our system is inconsistent with reality. Always you have some show results that were already processed and entered, and some earlier show results haven't been there yet, right? So the full consistency will be only achieved after a dog stops competing, sometime afterwards. But that's OK, because the system will self-correct, right? It will catch up those differences if there are any, and finally get the correct titles in place. And the last thing we learned is that best things happen when you get stuck. And what do I mean by getting stuck? So I think it's best explained when you talk about how it feels. So you're trying to do a simple thing, and it's just not getting anywhere. There's like so much friction in code. So maybe you have many tricky bugs mounting, or you try to add some feature, and it's just it seems so simple, right? And you feel stupid because why is it so hard? But sometimes those things happen. And when you read that chapter in the Blue Book about breakthrough, then Eric says, yes, that's hard. It's a big change. It's not something you can do in a day or two. It may be weeks, it may be months. And what's really scary is this change is so big that you don't know what will be your final outcome. You don't know how long it will take. You don't even know if you can pull it off, right? All you know for start is that what you have is not working, and we need something else. And And one thing I wanted to stress here is that this is not about clean code. That has nothing to do with the code quality, because your code might be perfectly clean, might be well tested, but the problem is that there's some fundamental misalignment between how things are represented in code and reality. So some core concept is not represented as it should, and that's causing all the friction. And it's really scary, so I wasn't kidding with those sleepless nights, and I felt the same in another project when we hit that moment. But what is really powerful about breakthrough is that I agree with Nick Thune on this one, that it's probably one of the most important concepts in DDD, if not the most important. And of course, when you hit a breakthrough and you realize that that's what it is, and you decide to change your model and you find a better model, then you will get unstuck, you will implement that new functionality, and you will fulfill the requirements that you knew about. And that's very important, that's very powerful. But what I think is even more important is that in many cases, that will open up new opportunities. It will inspire new ideas. And that certainly was the case for us. So we had a lot of new plans as a result of that new implementation, new possibilities. And I think that's what really DDD is all about building software that allows you to do great things and enables your business to innovate and constantly discover new stuff. So that's all I had for today. Thank you.